When talking about validation, there's essentially three things we need. We need a way to define our validation rules, we need a way to check them, and we need a way to report these validation errors to the consumer of the API. Mind you, we don't return those errors to let the consumer know whether they or the server made a mistake. That is what the status codes are for. However, often the response body contains a set of validation error messages the client application could use to show to the user of the application that consumes the API. Let's start with part 1, defining validation rules. Most applications require some rules on their objects, be it on a DTO, a business or domain object, or an entity. If those rules don't check out, a request should be halted. To create those validation rules, we can use ASP.NET Core's built-in approach, or a third-party component. In ASP.NET Core, the default approach for doing this is using data annotations on our properties or classes. These annotations can be built-in or custom. For all common property validation rules, annotations exist, like required or max length. Next to that, we can, as said, create a custom attribute for that. Another way to add some custom rules is implementing the iValidatable object interface on the objects we want to validate. In the upcoming demos, we'll look into all three different approaches. But that is just implementation. From a conceptual point of view, what's of importance is what we want to validate. A common rule is that we typically define validation rules on input and not on output. So, for data that is inputted, like when creating resources, but not for data that is outputted, like getting resources. This again drives home the point that we should use separate DTOs for separate operations. And that brings us to step 2, checking validation rules. For checking validation rules in ASP.NET Core, the built-in concept of model state is used. The model state is a dictionary containing both the state of the model and model binding validation. That's the part we need. It represents a collection of name-value pairs that were submitted to the API, one for each property. It also contains a collection of error messages for each value submitted. Whenever a request comes in, the rules we defined in step 1 are checked. If one of them does not check out, the model states is valid property will be false. And this property will also be false if an invalid value for a property type is passed in. So that's what we'll use for checking our rules. That leaves the final step, reporting validation errors. When a validation error happens, the consumer of the API needs to be notified. It's a mistake the client made, so that warrants a 400 level status code. There's one that's specifically used for this, 422 unprocessable entity. As we learned before, this 422 status code means that the server understands the content type of the request, so a 415 unsupported media type status code is inappropriate. It also means that the syntax of the request entity is correct, so a 400 bad request status code would be inappropriate. But nevertheless, the server is still unable to process the contained instructions in the request. For example, the syntax is correct, but the semantics are off. And that is exactly what happens with a validation error. But when we say reporting validation errors, we're not only talking about the status code. We're also talking about what will be in the response body. And that is not regulated by REST. But as we know by now, ASP.NET Core reports issues using the problem details RFC. We will look into that in detail soon. But first, it's time for a few demos. We'll start with validating input with data annotations.